Hello students, welcome to all of you in my YouTube channel. I am Dr. Himanshu Sarkar. In my last few lectures, I have discussed the electric field intensity due to dipole in the end-on position, in the broadside position, like this torque on the dipole. Also I discussed in my last classes how to find the electric field intensity due to continuous charge distribution, especially if charge lies on the ring or the charge lies on a rod, uniform rod like that. How to find intensity in this case? Last classes I have discussed this. Today I will discuss very interesting fact that is called the dipole oscillation. This thing is very much important for all of you who will appear for the JEE and NEET and other like competitive exams. Before that, I request to all of you to subscribe my channel so that you can get all of my channel views. Now write down the dipole oscillation. Remember, I told you in my last classes that is if E is the electric field intensity and a dipole is placed in this electric field. This is dipole, this charge is plus q, this charge minus q, length is 12, this angle is theta. This axis of the dipole makes an angle theta with the external electric field. And in my last class, I have discussed what is the expression of torque acting on the dipole. Torque acting on dipole is equal to what? That is a P E sin theta. Torque is what? P E sin theta. P is called dipole moment. E is the electric intensity and theta is the angle. P is the dipole moment. P is the dipole moment. Again I am discussing this is a dipole, charge plus q minus q. This dipole is placed in an external electric field E, make an angle theta, length of the dipole 12, torque acting on the dipole P sin theta. Already you have discussed in my previous classes. Now, very interesting fact is that this is a dipole, you displace this dipole, equilibrium position, you displace this dipole here, like this. Then what will happen? Then it can come back to the original position due to some restoring torque. You know the term restorator. Restorator means the torque by which it can come back to the original configuration. If you slightly displace the dipole from the angle theta, okay, then we can write down the restoring torque is equal to what? Minus Pe sin theta. Why minus sign? Minus sign means direction towards the mean position. Tends to move towards the mean position. Hence the name minus sign. Already you have heard the name of the restoring force or restoring torque where? In simple harmonic motions in class 11. Okay? So if I consider theta is the torque defined by tau. Torque is divided by tau. If we write down theta is very small, then torque is equal to minus Pe into theta. Because theta is very small means what? If theta very small, then sin theta tends to theta. So the torque is equal to minus Pe into theta. So no problem. Okay. Now, you know what is the meaning of torque in class 11 part, rotational dynamics? Well, you know, torque is what? I into alpha. I is what? Moment of inertia. Alpha is what? Angular acceleration. Okay. Torque is equal to I into alpha. I is called what? Moment of inertia. I is moment of inertia I is the moment of inertia, and alpha is the angular acceleration. Angular acceleration. So torque is equal to, from this equation, minus PE into theta. Torque is equal to what? I alpha, that is minus PE into theta. Okay. So what is alpha? Alpha is angular acceleration, that is denoted by d2 theta dt2. That is the angular acceleration. So I can write down I into d2 theta dt2 is equal to minus p theta. So d2 theta dt2 is equal to minus p by I into theta. That is suppose equation number 3. What you have learned? d2 theta dt is what? Angular acceleration. Theta is what? Angular displacement. P by I is what? Constant. So angular displacement proportional to minus displacement. Okay. So angular acceleration is proportional to minus angular displacement. So this motion is called what? SHM. Remember SHM? Simple harmonic motion. So acceleration proportional to displacement in negative sign means SHM. For SHM, we know F proportional to minus x. F is what? Angular. F is what? Acceleration. Proportional to displacement with negative sign. That is SHM. Just recall it. SHM. So F is equal to what? Minus omega square x. So coefficient of x is what? Omega square. So comparing that, we can write down. So comparing that, P by I is what? Omega square. That is what? PE by I. So omega is equal to what? Omega is what? Angular velocity. Omega is called angular velocity. So I can write down. Omega is equal to root over PE by I. Omega is equal to what? 2 pi by time period. T is what? Time period. T is time period. So T is equal to what? 2 pi root over I by PE. This formula is very, very important formula for doing the numericals for the students who will appear for the JEE, NEET and all other competitive exams. This formula is very, very important formula. I think all of you clear. If any doubt, you can contact me via WhatsApp number. WhatsApp number is given in my description box. You can check it. Thank you. I am stopping my class.